nodal analysis. Okay. First, we will see node. Node. It is the point of intersection of two or more branches. Next, one word comes branches. We have to know what is branch. Now, a line is joining one network element or combination of elements between 2 points. That is called a branch. Reference node, the node that is connected with the maximum number of branches is known as a reference node. Let us assume this one is a network. This one is network. Here node is this one is a node A, this one is a node B, this one is node C, and this one is node D. Okay. Node means it is the point of intersection of two or more branches. Branches means a line is joining one network element or a combination of a network element between it. Okay, here is a line. This line starts here and up to here with a network element. So a line with a network element or combination of a network element is known as a branch. So this one is a branch. This one is a branch. This one is a branch. These are branches. Okay. Note the line, the point of a intersection of a lines. Here is a line intersection at this point. This is a node. Here is a line, intersection point this is a node, this is a node, this is a node, this is a node. Then a reference node. We should take a node which is a point where maximum branches are connected. Here maximum branches connected. So this is the reference node. Here 1, 2, 3 branches connected. Okay. Here 1, 2, 3, 4. We will also take. But for our convenience in solution, okay, for getting easy solution, we will take this as a reference node in this circuit. Whereas as per definition, we should take a reference node where maximum branches are connected. Okay. Procedure for nodal analysis. Procedure for nodal analysis. To solve a circuit is by nodal analysis. What procedure we have to follow? First of all, count the number of nodes. First, count the number of nodes. Second, designate a reference node. That means we have to choose a reference node and point out that node as a reference node. Which node we have to choose? Node connected with the maximum number of branches. And all other nodal voltage will be calculated with respect to this reference node. Let's label the nodal voltages like V1, V2 up to Vn. Pay attention that there are n minus 1 non-reference node. If I have a n number of nodes, if I take one node as a reference, then how many non-reference node? n minus 1 non-reference node. So equation depends on number of non-reference node. So n minus 1 non-reference node means the number of equation equals to n minus 1. That's write the KCL equation for all non-reference nodes. Okay. Express any additional unknowns such as currents or voltages other than nodal voltages in terms of appropriate nodal voltage. Dependent source appears in our circuit. In case of dependent sources, appears in our circuit, we have to replace these dependent sources with the respect our one of the nodal non-reference nodal voltage. Okay, we have to replace the dependent voltage or current source with a non-reference voltage source. Next, organize the equation group in terms according to the nodal voltage. We have to organize number of non-reference equations. Okay. Next, last 7 number. Solve these equations for getting non-reference nodal voltages. Okay. These up to 0.7. These are the procedure of solving a circuit by nodal analysis. Okay. Inspection means by watching by the thought of our mind, by inspection. If a circuit is independent current sources, nodal analysis by inspection, we can apply that circuit which circuit has only independent sources. Independent current sources has n non-reference node. Non-reference node number, n number of non-reference nodes. The total voltage equation can be written in terms of a matrix like that. In terms of conductance, G11, G12 up to G1n up to like this. N number of nodes, n number of equations, and we can write like this. Where JKK, here JKK means GKK means G11, G22. These are this value, and these are the diagonal values. JK at the value, the sum of the conductance connected to node number of K. That means node number EB G11, node number 1, number of conductance connected to node number 1. Then GJK or GK. That means G of 1, 2. Or G of 2, 1 like that. Here the negativity of the sum of conductance connected between these two nodes 1, 2, 1, 3, 3, 5. So these are the negative sum of conductance connected between these two nodes. Where JK not equal to K, not equal to K. Just where the VK, the unknown voltage of a node, I get the sum of all independent current source connected to node number of K. Entering current taken as a positive and leaving current taken as a negative. This all about your nodal analysis by inspection. When we solve a problem based on inspection, you will get more idea about this. Okay. Supernode. Okay. And on supernode, what is supernode? A supernode is formed by enclosing a dependent or independent voltage source between two non-reference nodes. Then if we draw a circuit, कोनो साउंड को करें here is a voltage source between this node and this node. So these two nodes, let node A, B, C, this is reference node. Okay. Between two non-reference nodes, if there is a dependent or independent voltage source, these two nodes are treated as a supernode. That means this is a supernode. This is a
ना डेस्ट नहीं
Super.
प्रोटेक्ट कैमरा
Current entering this
प्रोटेक्ट
node
कैमरा
or leaving
प्रोटेक्ट कैमरा डेस्ट नहीं
will treat it as a single node. Okay. So this is a super node. Analysis of to procedure number 3 similar to कौन हो कौन this is similar to simple nodal analysis. Count number of nodes. Second one, designate a reference node. That means the node which is connected to maximum number of branches. The node that is connected to maximum number of branches known as a reference node. Third one, label the non-reference nodal voltages. Will be node number of nodes n. The non-reference nodal voltage n minus 1. Non-reference nodal voltages V1, V2 up to Vn will label. Next fourth one, if the circuit contains voltage source from or a supernode. यदि गोटे सर्किट गोटे वोल्टेज सोर्स अच्छी से गोटे कौन कर सुपरनोड तैयारी कर अबाउट ईच वन दिस इज डन बाय एनक्लोजिंग द सोर्स इज टू टर्मिनल एंड एनी अदर एलिमेंट्स कनेक्टेड बिटवीन द टू terminals within the broken line. Okay. If a voltage source with some element or simply a voltage source within between two non-reference nodes, that two nodes considered as a supernode. Okay. Like write a KCL equation for each non-reference node or supernode. For each supernode or non-reference node, we have to write a KCL equation that does not contain the reference node. Okay. Sum of the current going into non-reference node or supernode from a current source is right one side and other current source leaving or flowing out from the node, non-reference node or supernode is right in another side of the equation. Equation means there should be a equal sign if sum of the entering currents. Sum of the entering currents in one side, sum of the leaving currents in one side. While writing this equation, you have to pay attention to the side. Pay attention to the side. Okay. When we writing this equation, the sum of entering current, if we take this right side to left side, we have to minus sign it. Sum of leaving current equals to 0. During this time, you should pay close attention to negative side. You have to change your sign when you are replacing equal sign. The equation equals to 0. Okay, during this time. Then procedure number 7. The relate the voltage source across each voltage source to nodal voltages. This is accompanied simply application of KVL. We have to keep a voltage source. There is a voltage source between the two nodes. We applied here it is these two nodes treated as a supernode. These two nodes are treated as a supernode. We know to calculate unknowns. We require that much of a equation. We have to calculate that much of unknowns. If we have a two unknowns, we require two equation to calculate two unknowns. If we take this is a supernode, so we get applying a supernode analysis. We get one equation. We need another equation to calculate to find the nodal voltages. That is, this is V1 or V2. We have to calculate V1, V2. We need another equation. Here some voltages, 10, 15, whatever may be something voltages. We have to apply here. We have to apply KVL. After KPL, we find one equation. By nodal analysis, we have already equation. We have two equations. We have two unknowns, B1 and B2. Simply, we have to calculate these two equations. We have to find it B1 and B2. Or supernodal express any additional unknowns. That means any dependent current or voltage sources. Of course, with the appropriate nodal voltage. And any dependent current or voltage sources, we have to express that current or voltage sources in appropriate nodal voltage. Then 8 number, similar like it. Nodal analysis, organize these equations in terms of nodal voltages for finding nodal voltage. Okay. Number, these are the procedure for finding nodal voltages of a circuit which contains a super.